Going to present a session, technical session on solid principle in OOP. So before going into deep dive, let's know about OOP because as the topic says that the principle have to follow on the OOP. So let's recap on what is OOP basically. Most of us who know, those who are doing the developing, so they know the OOP, but those who didn't know the OOP. So the OOP is basically a programming paradigm that's basically uses in the software industry and basically organize our software into around the object rather than the function or logic, the traditional one. So what is the benefit or the uses of OOP? So OOP basically have so many benefit regardless on the traditional functional programming. So it basically makes the code modularized and the reusable. Also, it makes this code more maintainable in terms of reuse, and it also makes complex software system into breaking down into smaller chunk. So, and on this OOP, basically we use so many principle, and among them there is one solid principle, and it's just in name, and the solid has also the meaning. So let's go into it. So what is the solid principle? It's just it is basically introduced on 2000 by Uncle Bob, which is renowned by his name. And before going to know more detail on solid, why basically we need to use, as I said earlier, the why we use OOP, because the code modularity and to reduce the function or logic into the object. And the same way, if I say the solid is the five, there is a five letter you see, SOLID. So each have different name and different meaning on this. So each have if I say is a solid is basically used the same way, and the OOP wants to we use for reusable, the same way we want to use the solid to maintain more cleanable code on our OOP side. And if I explain this five letters in this way, like for the S, it is replace the single responsibility, the O meaning the open closed, the L Liskov substitution, the I for interface segregation, and D for dependency inversion. So let's deep dive on to each one so that you can understand what is the exact meaning of AS or A or LID. The first one, we have this as the single responsibility principle. So if the definition says that a class should have only one reason to change, it means a class module. So before, if those who know what is a class in OOP, basically we maintain the code in a class, and this class basically used in separate way and separate section, and we use the object of its class. So that is how basically OOP works on our programming. So what the principle says that a class should have only one reason to change. Suppose for that means you can't change it in multiple for multiple reason. So let's give an example. I think that will be clearer to you. Suppose let's imagine a restaurant where you see the chef as there, the waiter is there, the manager and the other stuff is there. So you see the chef is not like ordering food, or chef is not like taking the food or giving you the food on your desk. What it does, the chef basically does the cook. So he's not responsible to take the order or serving the food. So that's the same way. If you see the waiter basically didn't cook, he or she basically takes the order and serving the food, and then instruct the cook how he wants the customer wants the order. The same way, if we have, for example, the manager or the other person, those who take the cash from the customer or maintaining everyone. So if you see there's just so many people, I just took the three, but there'll be other people on the restaurant side. The cleaner will be there, the owner will be there, so everyone have the separate rule. and they are doing the job. So if someone like the cook comes into the waiter's role and he takes order, and also if he cook the food, so what happened, everything will be mess. So that is what the same thing, if cook only does his cook, so what happened, he will do his job and the waiter will be just taking the order and serving the food. So that's why it will be the own responsibility there, so everyone will be responsible for their own work. So same way, if I go into the code, so the principal says the class, if you represent it in this way, so the class is only one reason. The same way, the cook has only one reason, like he needs or she needs to be cook. He is not like responsible for the other work. So same way, the class have only one reason. So it shouldn't be the other reason to change. So let's give a code example so it will understand more. So there's a code without this single responsibility. So if you see, there is a class and there is a three method, what you call an method. The three, you will see the fetch user data, save user data, and the build method. So there are three different method, and the three different method have their own work. And inside the class, all the three method is been added. So let's see the other example. Those who like this one is that those who didn't follow the single responsibility principle, and what happened when we use the single responsibility principle. You see, we have separated the class into another class. So before that, we see every function or method that we called, that is inside the user profile page. Not now what we do, we basically separate the class named user service and added the two separate function, those who have basically handling the data towards the API. So the fetch user data and the save user data have the two function, those who basically fetch the data from the API and also save the data. And these two methods are inside into the separate class user service. So if you see, the user service is separate rule. So only there's one condition. So if anything wants to change on this method, or you will just call the user service. So we will not bother to use the build method, because build method is someone that is always called for the UI purpose. So let's see the on the bottom one, that the class user profile page, basically we are extending or we are calling the object of user service name as a user service, and we are using this on our class. And the build method has, you see on the bottom, it has separated. So the user profile page, the class itself has a build method, and it is responsible to show the user the UI. And the other things, anything come from the API or even this API, that means the network things and the saving part has to handle by the user service class. That's how we are basically separating everything into one class, that the responsible has the user service to like fetch or save the user data on the API. We are not using all the method inside a class, and there is the one class is not responsible for only one reason to change. So they have the separate reason. So the bottom one has a reason to change the UI using a build method. The above one using have the reason to change the both the method based on the UI API. So that's how we can use the principle on our code. So if you go on the other principle, the open close, what it says, software entities should be open for extension but closed for modification. So again, let's give an example so that it will good idea. Suppose we in our company we have policies that basically uses in so many areas. So suppose in certain times or in future there's a issue comes or there's a modification comes, so what do? We basically use our existing policies and make some adjustment. So we are not like modifying everything, or we are not rewriting or editing everything. We're just doing the exact part that we need. Like if anything modification needed, and if anything added to needed, we just adding on this existing policy. suppose someone, let's give an example. Suppose someone, there is a condition comes where remote works needs to be added. Suppose there is no policy for the remote work in our company policy. So what happens, we are not like modifying everything to edit the remote work policy on our existing policies. We're just doing the extension. So let's see, maybe I can give you more examples so that it can be more clearer. Suppose we all use mobile phone on our daily life, and we have so many different operating system on that. So suppose we have Android, iOS, or other system. So on this operating system, we use so many apps we install as like we need. So what happen if we think about, like, in a way that the operating system basically doesn't, we are not modifying this operating system, we are doing some extension on this. We are installing app, we are using another app, or we are any service or anything we use on our app. It's just an extension, we are not modifying and the entire OS. So this way you can say the principle is likely about this. So we are when we are doing the code, we will not modify everything, we're just doing the extension. So give an example. These are service that basically doesn't follow the open close principle, because the notification service, you see both the method inside the notification service, the send email, the send SMS. That means if I use the send email, we also used to use the notification class. If you want to send SMS, you also want to use the notification service. So if you see the first principle also break on this class, we are not changing each for different reason to change the notification service. So if we break down and use the principle, what happens, we see, you see, we have separate this into the notification channel as an abstract class and make the send method inside this. So if you see the previous example, there is a send email, send SMS, two different methods there inside the notification service. But in this example, we see we have made an abstract class, the send method, which is didn't use anywhere. So we just use the abstract class. And now if we see on the bottom, there is two different class we use and implements this. Those who know about the abstraction, we use this OOP principle here. So email notification is basically implement the notification channel. So those who know the abstraction, we know that if any abstraction happens, so those any method is declared on the abstract class must be overridden on this child class. So you see the send method and the and top above the override annotation is called. So the send method we can reuse on this email notification. So any particular things or logic we need to use inside the send method we can use. And the same way, if you see on the bottom on the bottom and middle one, SMS notification, the same way it is basically implement the notification channel. So you have to use the send method, and you can use our own need, like send SMS notification could be logic of sending SMS to mobile phone. Email could be sending to any email, any kind of email. So there definitely there will be different kind of logic will be there. So that's how, if you see the open close principle says, like it could be open for extension but closed for modification. That, so if you take a look, like we are not modifying the apps notification channel, the top one. We're not modifying, we're basically using the send one, and we are adding an extension, because the same send method is used for the email, same send method for use for SMS on. And also if we more do the extension, suppose we do the push notification, the same way we can do. So what it does, like we are adding an extension, but we're not modifying the master one, the top one, the send one. So that's how the principle says we are. It should be, sorry, it should be open for extension but closed for modification. So we are not modifying the main one. We are not. So we are just doing an extension, and we are overriding is this one and use our own way. So let's go on. Other principle, the Liskov Substitution Principle. What it says, it says that object of a superclass should be replaceable with a subject of subclasses without affecting the correctness of the program. What it mean? It says that when we use the superclass and the subclass function, like the inheritance that we use in OOP, it says that when we are dealing with inheritance, the subclasses when we subclass the use, it should be the same functionality based on the superclass. It could be like there will be no what is a like difference will be there. The same functionality will be there. So let's give an example so it will be more clear to you. From the real world, I'll say, if I say, suppose give an example of printer. So we know the printer, what it does, it basically print an object, document. So we expect to from the printer that if I want to print a PDF or any image or anything, the document it would be printed to out. And if you see the printer, if we think about, it's a superclass like printer. So many printer will be there. There will be laser printer, there will be uh, a linked printer. So many printer will be there. But if we make printer as an superclass, and all the printer will be coming under the main printer. So the laser printer or inkjet printer or maybe 3D printer. So everyone is a printer, but the main class superclass will be the printer. So if we make an example or make a comparison with this principle, what it says that superclass or and the subclass, if anyone uses anyone, so it can't like affect the main program of its superclasses. So suppose I use the inject printer, so it should be print the object as like the normal printer do, like the main superclass. So in way, if we use the laser printer, it should be do the same thing or same program it must be do as like the printer do. Same way, if we go in the 3D printer, it should be. But what it if we use the 3D printer, which is not basically for normal print document or normal document, it's to be printed. It basically use the 3D object. So does it make sense? Like it is using the superclass and also is it maintaining the correctness of the program? Definitely not, because the printer says it should be printing the document, normal document, but 3D printer is not printing any document. It printing the 3D object. So that is how, if you see the example, the printer has a superclass and the subclasses, the inject and the laser printer is basically following the superclasses, but 3D printer is not following the this principle. So also I can give a more example. Like when you rent any car or any vehicle, it like if you see the vehicle as a top object, like the car should be a vehicle, the motorcycle, the bicycle, everything is a like vehicle. And if we compare the vehicle, basically the truck will be also there, the other will be also there. So if you put that vehicle as a superclass, like you expect like vehicle should be run, you can use or you can drive and so if you compare with the car with the bicycle, does it make sense? Because bicycle also is a vehicle and also car, but does it follow the principle? Definitely not, because car has brake, car has steering, car has something what do you call uh the speed function and other things which automatically will be there, but the bicycle will be not there. So if you see the example, the if should be it would be into the superclass, it must be follow the same correctness of the program. So let's see an example, more example on the code, so it will be more clear to you. So you see there is a three classes will be there, which is it doesn't follow the Liskov substitution. There's a abstract class, bird is there. There's a class that inherit the bird is called sparrow, and the penguin basically also extending the bird. But you see there's a, as we said earlier, the abstract class method must be overridden in the subclasses. So the sparrow class basically extended the fly method, so does the penguin. And you see the fly method in the bottom, there is an expression throws that penguin can't fly, because penguin is also a bird, but it has no is not functionality to fly. It can swim, so fly basically put on the sparrow. It the logic could be on this sparrow one will be right, but for the penguin it will be right. So that's how it basically it's not following the list of substitution. So let's see how you can follow the list of substitution. You see in this example, we are making the Liskov substitution principle into the part has a sorry, separate class in the bard, and the bard has been used as an extension. And you see the flying bard has also all the method, which is basically extend the bard and has method the fly. The same way you see on the bottom, we have two different class, the sparrow and the penguin, but these are not extending the same class. The sparrow extending the flying bird, because in flying bird we are basically extending bird and that has separate method. We are modifying, not modifying, the you see the two example. In this example basically we use both the open close principle. We are extending the flying bird as, and but not modifying the bird class. So as in same way you see the LSP one, so the list of substitution, we are basically only checking that subclasses and superclasses must be follow the same principle. So the sparrow using the flying bird, that's how, and so that the fly method should become on the overriding, and must be the sparrow can fly. And the bottom you see the penguin extend but not flying bird, because flying bird has the method to fly and it has a different section, but normal bird has can be fly, can't be fly. So the penguin has this different method swim, because it can swim, so it can extend bird, and we can use our own method swim. So that's how we basically differentiating all the classes and making this in a way that superclass and subclasses at least maintain the main program of its superclasses. So the bird has no method, so that's why it is we can extend everyone, the flying bird on normal bird, so that it can separate it into two different ways. So let's go on to the other principle, the interface segregation principle. Uh, so client should not be forced to depend on interface they do not use. What does it mean? So let's go on to directly example, so it will be more clearer. So again, come to the restaurant example. When as a customer we went to the restaurant, what do we do? We basically check the menu. So suppose I have a determination, or I have determined that I only take the dessert, or I only take the platter or something. So what did it make sense that I can go all the menu from the menu book? No, I'll just check, or I'll find whether the uh, what do you call, uh, the menu or dessert will be there, section will be there. So I'll definitely go on the dessert menu and then pick anyone that I choose, and then make an order. The same way, the principal says the client or that user must not be forced to an interface, or like must not depend on the interface they do not use. Like what they are not using, we are not too forced on the code side. So same way, if I give an example, in real world, you all do sometimes do the buy the subscription on any app or any particular product. So we are not forced to buy the main like all the product subscription. We have the specification or differentiation on different uh, subscription, like the basic, normal, or premium, on that will be there in any app. So we are not bound to stick into one subscription. Rather than we have the option, if we need like the daily subscription, we can buy the daily one. We can, if we need the monthly, we can do the monthly, or if we need the yearly, we can also do the yearly. So that's how it's up to me, like what we need, I need to choose, I what based on my need. You can't, like the app owner or the product owner can't be forced me to buy the full subscription or full like I don't need to. If I need the daily use, what is the purpose to buy the full year subscription? So that is how the principle says that only depend on what we use or what we need. So let's give an example. There is an uh, the example that doesn't follow, if you see, and there is another example that we follow. So let's compare with each other. In this example, the abstract class payment processor has three different methods: process credit card, PayPal, and Bitcoin. And when we use this abstract class as an interface, and we use the implements, then all the three methods needs to be used because of the abstract method. And because abstract class has three different methods, it needs to be overridden when you use the abstract class. So that is why, because if someone wants to use only the credit card method, we have to also use the PayPal method and the Bitcoin method. That is not a good way, because the principle says it should be depend on what they use, or at least the minimum use uh, uh, of the code. So, and in this example, you see we have making three different abstract class. One is the credit card, one is the PayPal payment, one is the Bitcoin payment, and that's how we only depend on single method or single class. But before that, we have, if we use the payment processor, we have also need to use the three different method, even if I don't need to. But in this example, you see we have making this into different classes. So if anyone wants to use the credit card, he can just call this credit class and implement this, and we had to only use this or override in the process credit card payment method. So the bottom one you see, so we're not bothering about the PayPal one, we're not bothering about the Bitcoin or any other payment processor. So that's how basically the principle says we only need to use the exact interface that we need to use. So going forward to the last one, dependency inversion principle. That's it says the high level modules should not depend on the low level modules. What does it mean? The same way, if I give the example of the previous one, again the if anyone goes on the e-commerce website, we need to buy, right? So, and there's this different payment method will be there. There'll be PayPal, Bitcoin, a mobile banking system, or credit card, or banking system. So many things will be there. So what we do, from the code level or from the developer perspective, we are not using or not implementing each payment implementation on our code. We basically use a third party like the payment integrated service, or any other service that we use. Because why we are using the third party or payment gateway? Because it is our job, and it makes an abstract, or it makes make a bundle to do the job. We are not bothering to implement the credit card payment into our software, not bothering to mobile banking system or any other payment system if we need to use. So everything has a bundle, which we call the payment gateway, and we are not bothering anything to handle anything. The rest of the use handle will be handled by the provider. So that's how the principle also says, like the high level model shouldn't be dependent on a low level model. What does it mean? If you compare the e-commerce website, it doesn't depend on the payment system. Like if it is only depend on the credit card system, that there is nothing the point to follow the principle. It definitely break the principle. So same way, if I give in the code, so let's see, so it will be good clear to you. In this example, which is doesn't follow the dependency inversion, there is a class in the top SQL database and have the method save data. So when you use an object of its class, in the bottom you see the class data repository, you have an object database, which is basically representing the SQL database, the verb class. And we are using this save data method inside the save method in the data repository. So how the principle is not following is there, because we are following, or we are like completely dependent on the SQL database. We are it might be see that it is a good code, or it's something, it doesn't break anything. But if we see more in a depth, like we are like now depending on the SQL database, and see if any extension needed, or if anything a modification needed in future, like we want to use the NoSQL database. So suppose what needs to use, we have to also like separating everything, or we the separating all the method for that NoSQL. So that is how the dependency will become, because we are already dependent on the SQL. So in future, if we want to use the NoSQL, there will be definitely so many rework will be there. So that's how you see the principle is not following on this. Let's see how we can follow the principle. In this example, you see we are again making the database in an abstract way. Previously it was only the SQL database, and there is no point to extension. And now you see the database has separate class, and the save data method is inside there, and we are using the two different class, the SQL and NoSQL, and implementing database. So that's how we are also following the open close principle. So we are not modifying this database, we are just implementing or extending the open close principle. And the SQL database and NoSQL and any database, if you want to use, you can use so far. And that's how basically we are using the dependency inversion also. We are not depend on any specific method or specific class on that. We are just depend on what we need. So if you in the bottom, if you see, we are making an abstraction in here. We don't even the data repository is not known like which database we are using. We only when it will be known when we make an object of SQL database or no SQL database and use this method directly on other part of the code. Only that time we basically know the exact use of the SQL and no SQL. So that is how we make an abstraction here, and we are making each module dependent on itself, like we are not dependent on any other method or any other class, and that's how basically we are following the principle.